What if I told you that building enterprise AI agents does not have to be chaotic? Today I'm breaking down a production ready architecture that handles everything from traffic routing to regional deployments, all in under few minutes. This is an enterprise agentic framework. Think of it as your AI traffic control center. At its heart, we have the AI gateway acting as our central hub. It's not just routing request, it's your API product layer that handles authentication, rate limiting, and request orchestration. Notice how agents on the left connect directly to this gateway. This is intentional. We're keeping the agent layer clean and focused, letting the gateway handle all the complexity of the APIs. Let's trace a typical request flow. Your agents hit the AI gateway, which immediately checks the policy.xml layer for security and governance rules. Meanwhile, the cache component is working behind the scenes to serve frequent requests instantly without going or touching the backends. From the gateway, requests flow into the backend pool. This is where the actual magic happens. We have got specialized LLM backends for language processing, embedding backends for vector operations, especially that are useful for caching. And let's not forget about content safety for moderation. And you have existing enterprise APIs that has been around forever. This is where the business logic for your enterprise exists, and therefore time and again we need to reach those enterprise APIs to get your enterprise data. And usually we don't directly touch enterprise APIs but expose your enterprise APIs and our enterprise data using MCP servers. So you use MCP server as a backend to connect to either of these components. Here is the key insights. Enterprise data is not directly connected to large language models. It is not a best practice, and that should be avoided at all costs. LLMs, by virtue of agents calling these endpoints, operate off of something called MCP server. MCP stands for Model Control Protocol. This means your agents can access real business data without complex integrations. So that way, you can fetch the context to your large language models all from within your enterprise backends using APM as a centralized layer. Now, here is where all of this gets enterprise grade. Everything flows through AI Foundry models. You have seen the recording from my last recording. If not, like go check my YouTube channel. We have spun up a fully functional AI Foundry across several different regions. So we split almost always every organization split their deployments as regional deployments for obvious reasons. There could be quota limitations, there could be compliance requirements such as data sovereignty and scaling. All of these are reasons why we will almost always have many regions deployment. And in this case, API manager is acting as a load balancer. So why does this matter for you as a developer? Separation of concerns is a simple answer. Your agents focus on logic, not infrastructure. We have built-in observability. Every components in this flow can be monitored and optimized independently. And lastly, the policy and content safety layers handle governance automatically. The animated flows you are seeing represents real request paths. When you hover over the components, you can actually like start learning about each and every component as I am hovering through this. And it itself is an exercise, and it comes with practice and further thinking about enterprise grade standards. This framework handles the complexity so that you can focus on building intelligent agents. Enterprise AI isn't just about throwing chat GPT at your problems. What you're looking here is a production grade enterprise agentic framework that many large organizations use to deploy AI at scale. I'll walk you through every component and every flow in this architecture to take you deeper into how an enterprise AI deployment looks like. Starting on the left, we have our agent ecosystem, and this is more sophisticated in the perspective of we have foundry agents, which are your custom built domain specific AI agents, out of the box agents. Example, the common scenarios like Databricks Genie or Fabric Data Agent or ServiceNow agent or any other Microsoft 365 agent that comes out of box. So the Copilot Studio, which is the Microsoft low code agent builder for business users. So all of these agents funnel through an orchestrator. In this case, it's a semantic kernel orchestrator, which is Microsoft's enterprise grade orchestrators for orchestrating your agents. So this is not just a router, but it is a brain that coordinates multi-agent workflows, handles complex reasoning chains, and manage agent-to-agent communication. Think of it as your AI traffic conductor. Now coming to the meat of this architecture, the gateway layer. Everything flows through your active-active AI gateway setup. Notice that active-active designation. That's enterprise grade high availability, no single point of failure. The gateway connects to Redis for lightning fast caching. You don't need to use Redis, but I chose Redis to be my external cache. And Azure has a managed component of Redis. We are talking about sub millisecond response times for frequent queries, and you will see this in a demo in a little bit. It enforces policies in the form of policy.xml for all of the APIs that you would be creating. The governance layer with, that is built around this policy.xml handles authentication, rate limiting, content filtering, and compliance rules. So one of the typical example of authentication or authorization checks is JART validation. Here is the great future. The gateway exposes everything as API products. Think of AI gateway as a facade for your AI APIs. Your agents aren't just internal tools. They are monetizable, distributable API endpoints. This is how you turn your AI investments into revenue streams. A backend pool architecture. Let's go to the backend pool architecture and see stuff in a little detail. This isn't a monolithic AI service. It's a specialized microservices architecture. LLM backends handle your language processing, GPT-4 models, etc., are all load balanced and optimized. Embedding backends manage your vector operations for RAG systems and semantic search. Content safety runs real time moderation. Think of it as your AI firewall. Enterprise APIs connect to your existing business systems, such as CRM, ERP databases, without breaking your security model. And MCP servers, the model context protocol or model control protocol, these are your bridges to enterprise data sources. Now let's talk about data layer integration. So, without data, your agents are just expensive chatbots. The enterprise data layer shows the full spectrum: data warehouse for structured analytics, data lake for unstructured content, and direct database connections. The MCP servers create secure, governed pathways to all of this data. Notice the enterprise subscriptions feeding back your data to your agents. So let's talk about Foundry deployments now. The AI Foundry models component is your competitive advantage. These are in generic cloud APIs. These are custom models, which could be fine tuned for your data, understanding your business context, speaking your company's language. From the Foundry, we deploy to regional subscriptions, region A, region B, etc. This is not just for latency optimization, but the variety of factors include data sovereignty, compliance, performance, cost optimizations. So, why does this architecture matter? Let me talk about four benefits in the order. Scalability. Each component scales independently. High LLM demand, scale just the LLM backends. More embedding requests, scale just those services. Security, multi-layered security from the gateway policies to MCP protocol encryption. Your data never leaves your control boundary. Observability, each and every component reports metrics. You can track cost, performance, and usage patterns across your entire AI estate with built-in observability that you could hook each and every components and its telemetry to um, your observability platform that is built on Azure Monitor and Application Insights and Log Analytics. Flexibility is the fourth one. Want to add GPT-5 that came very newly? No problem. Just add it to your backend pool and all good to go. No front end user need to know which model you're using. So this architecture adapts to your changing needs. This is a production AI architecture, not a demo or a proof of concepts. Companies are running billions of AI requests through systems. Let's look at the Python notebook wherein we are calling API management gateway along with Redis cache configured. So if I'm going to make a call to API management endpoint, I have given my API management endpoint and the API management API key, the Redis host name, the port and password in my env file, and I'm not going to show you my env file. So they are there, and in a minute we will also go and check in Azure of how they look like. So I'm using simple GPT-4o mini model for the demonstration here, and these are some of the questions directly picked from Azure documentation for API management. So we are asking the questions such as how to brew the perfect cup of coffee, what are the steps to craft the ideal espresso. As you can see, these are set up for like similar questions if we are going to ask him again and again, like how cache would be useful. This is my API management endpoint. So this is the API management gateway URL slash. This is the inference is the path, and all the backends are configured behind that facade, right? So, and the backend contains, sure enough, GPT-4o mini model in this case. So this is just boilerplate code. I'm instantiating Azure OpenAI client. Nothing fancy. I'm not using agents or anything like that. Just simulating the direct open Azure OpenAI calls. So wrote some helper functions. Not big deal, right? So just to measure the cache hits and etc. later. So I created some helper methods, simple helper methods. So make OpenAI requests with cache and with no cache, right? So the only difference is, like when I do it with cache and without cache, obviously, like in this simple demonstration I'm showing you, I'm going and hitting the cached response, just an extra if statement that says if the cache is hit, then like don't call the backend API. But I will show you in the APIM the actual backend and how it could be configured with the Redis cache. It's just a one liner, okay? Is the same. Performance without cache, right? So let's say I'm asking these questions, I'm picking up the questions, I'm just making up 20 runs, right? So and without cache, the average is 0.43 seconds in this case. So let's say I actually run this cell with Redis cache, and as you can see, right, I'm just measuring cache hits or not. Right? So there are decent number of cache hits, and the performance obviously would be much better. And sure enough, it is 6. So let me quickly compare. So with these visuals for you, as you can see, performance without Redis cache, and performance with Redis cache. So it's there, uh, noticeable. Also, you can see the average response times plotted and the cache hit rate. So if the questions hit the cache 75% of the time, you get 86.1% performance. Nice, right? So we don't want to be wasting money and hitting the Azure OpenAI backends unnecessarily. And also, just just a typical cost savings mechanism, right? See, we are of course not making 100K requests. We'll be making millions and millions of requests every single day, if not every other day in an enterprise setting, and the costs add up. So, with that, I also want to show you how we can actually set that up in the backend. So, if you go to my API management gateway, this is the inference API I have set up. Let's go to settings. And if you go to the design, if you go to the backend, is the setting, right? So you don't need to worry about setting cache, looking up the cache and all, right? So Microsoft will take care of that as part of API Management Gateway. So all you have to do is Azure OpenAI semantic cache lookup, and you have to provide, of course, an embedding backends because it does vector comparison. So you need to have an embeddings backend ID. And my authorization is system assigned managed identity. So look how simple the policy is. And then, this backend service is for Foundry models themselves, right? So in our case, it was Foundry 1, whatever that backend is, contained GPT-4o model, GPT-4o mini model. Um, and, we are maintaining the cache for 2 minutes. After that, it would evict the cache. So, which is reasonable in this case. Given that setup, and all you had to do was, you had to provide this thing called external cache, and that external cache is my Azure Redis cache, and I have to configure this Redis cache, and that would be my cache, and that's it. You don't need to do anything else other than that. It's very simple, right? Yeah. So with that, I hope I'm not showing you every capability of API management gateway, but my attempt is, like, to show you how powerful API management gateway is, and how you could use it. I hope you will take this enterprise grade standard and practice, and extend the functionality to agents and the agent orchestrator, so that none of your enterprise data sets are exposed directly, but through MCP servers. You do enterprise best practices such as content management, uh, load balancing, honoring, like, the traffic from your load balancers for the location level things, and also diverting the traffic by API names or categories by properly segregating them into API products, and much, much, much more. And please don't forget that you can run API management itself in active setting and in enterprise, so that you can actually split your traffic 50-50 across multiple uh, APIMs. And in that way, you could not only load balance within APIMs, you could load balance across multiple APIMs. And also you could take care of your high availability and disaster recovery scenarios of the enterprise. Um, if you have any questions, drop a question underneath the video, or like, provide me the comments. I hope you enjoyed this session, and I really, really, like, hope that you would be you would be adapting these enterprise grade practices for your enterprise. Thank you very much.